Welcome to our video which considers the joint discrete bivariate case where we are given two random variables x and y that have a joint probability mass function, that is the joint f of xy, given by k times x plus y. X is discrete, that's what you've mentioned, with the value of 0 and 1, and y is 1, 2, and 3, and 0 otherwise. So the f of xy will not take will take a value of 0 when x is not 0 and 1 and y is not 1 and 2 and 3. So the first part is we want to find the value of the constant k. And the condition for any probability probability density function is that if you sum the f of x, it should be 1. If it's a joint, meaning you have two random variables, if you sum that, it should give you a value of 1. So based on that set of information, now we want to move ahead and solve this problem. So I'm going to start by summing over y for an easier over x, for the reason being that I would feel more happy to see how the values would change with respect to the values that I'll have introduced in. So if I do sum over x, in this case, we say we want to sum over x. That's what we want to do. So what we mean by this is we want to find out the summation over y when y is 1, 2, and 3, and when x is 0 and 1, and then we want to sum k of x plus y, and we equate that to 1 to be able to get the constant k, because that's the condition that should always be satisfied. So if I sum over x, I'll put k there. When x is 0, it's 0 plus y, and then when x is 1, it is 1 plus y, and therefore I'll be left with k sum over y, 1 plus 2y. Now I have three values of y. Y is 1, 2, and 3. Therefore, I'll keep k as a constant, and I want now to sum over y. So it will be 1 plus 2 times 1. And then the value of y is 2. It is 1 plus 2 times 2. And then when the value of y is 3, it is 1 plus 2 times 3. And that's what we have. And this should be equated to 1. That's basically what we have. It's 2 times 1. That is 2 plus 1. This is 3. This is 2 times 2 is 4 plus 1 is 5. This then 7. And all this gives me 15. So 15k is equals to 1. And this means that k is equals to 1 over 15. And that tells us we can write our f of xy to be equals to 1 over 15 x plus y. X is 0 and 1, and therefore y is 1, 2, and 3. So since we have the first part, we can move on and be able to compute the second part. Maybe we could be told to find probability of x is equals to 0 and y is equals to 1. And that basically means it is 1 over 15, 0 plus 1. And that gives me the probability of 1 over 15 that x is 0 and y is 1. What you could do is you could also come up with what we call a joint probability table. Joint probability table, whereby you put down the values of x and the values of y. So therefore, allow me to interchange this, whereby I write y stroke x. X is 0 and 1, and y is 0, 1, and 2. y is 1, 2, and 3. When, remember, our f of xy is x plus y divided by 15. So when x is 0 and y is 1, it's 1 over 15. When x is 1 and y is 1, is 2 over 15. When the value of x is 2 and y is 0, is 2 over 15. This is 3 over 15. And this is 3 over 15, and this is 4 over 15. Now am I getting 4 over 15? X is 1 and y is 4. This then is what we'll call the joint probabilities. The joint probabilities where both x and y occur together. And I can come up with the marginal probabilities, 1 plus 2, which is 3 over 15, 5 over 15, 7 over 15. And if I sum these, they give me 1. This is 6 over 15, and this is 7, 9 over 15. So these probabilities outside there, these are what we call marginal probabilities. And they are similar to this. These are also marginal probabilities, and the sum of probabilities will always be equals to 1. Well, these ones that are inside there is what we refer to as the joint probabilities. So what is the difference? The difference is 1 over 15 is probability of x is 0 and y is 1. Now, what about 6 over 15? 6 over 15. Then that's the marginal probability of x is equals to 0. The marginal probability of x is equals to 1 is 9 over 15. And the same case for the values of y. So that's how you'd go about that. The other things you can do with the same, what we are doing, and look at how to, at part C, we can want to find the expected of xy. And by definition, for a joint, you sum over y, you sum over x, xy times f of xy. And therefore, this, I can write it as sum over y. You can sum with x first or sum with y. We know this is 1 over 15 x plus y. So if you allow me, I'll put 1 over 15 outside there. Then I'll have y x squared plus xy squared. When I multiply xy times x plus y, that's what I'll end up with. Now, I know x is 0 and 1, so what I'm going to do, I'm going to substitute the values of x. When x is 0, so it will be 0 plus 0. And when x is 1, it will be y plus y squared. Therefore, I know this will disappear. I'll be left with y plus y squared when x is 1, because it will be 1 squared times y, which is y, and this one will be 1 times y squared, which is y squared. Then finally, I'm going to substitute the values of y, starting with the lowest, which is 1. It will be 1 plus 1. When y is 2, it will be 2 plus 4. And then y will be 3. It will be 3 plus 3 squared, which is 9. And so this is 2, this is 6, and this is 12. And what does that give me? That is 6, 8, 20. So it will be 20 over 15. And that is the expected value of x, y.